Operating an offshore drilling rig involves managing thousands of tons of volatile hydrocarbons while being battered by heavy ocean waves. In this environment, a single lapse in communication can lead to total system failure. On July 6, 1988, the Piper Alpha disaster was triggered during a routine 6 p.m. shift change. Earlier that day, the morning crew removed a pressure safety valve from condensate pump A. They filed the paperwork by physical location, leaving the permit for the valve removal sitting unseen on a desk, completely disconnected from a separate permit for a general pump overhaul. The night crew began their shift unaware the pump was compromised. When a primary pump failed, they attempted to start pump A. Because the safety valve was missing, gas leaked at high pressure and ignited, resulting in a series of explosions that reduced the platform to charred, smoking ruins and cost 167 lives. The investigation proved that the disaster was caused by administrative silos. When reporting relies on human memory and scattered paperwork, the handover point becomes a lethal vulnerability. Strengthening this process requires moving away from manual filing toward a protocol of active, verified reporting. The first step in the protocol is centralizing all maintenance data by logging into a digital permit-to-work platform. Paper-based systems are vulnerable to loss and misinterpretation. A digital dashboard links every maintenance task directly to a unified asset database, ensuring all information is instantly accessible to the entire facility. This software automatically maps active permits to their corresponding physical machinery, creating a real-time link between paperwork and the hardware on the deck. When the system recognizes an open safety permit, it applies a digital safeguard. A padlock icon appears over the equipment entry, and the software disables the start function until the permit is closed. Digitizing the system ensures that safety is managed through engineering controls that remain active regardless of shift changes. For the second step, the outgoing supervisor must initiate the digital shift handover module exactly 15 minutes before the end of the shift. Informal pass-downs are a primary cause of industrial accidents. Relying on an informal chat to convey complex technical data allows critical equipment anomalies to be omitted or misinterpreted. The digital module generates a comprehensive log. It auto-populates active overrides, well integrity data, and ongoing tasks into a single view, marking suspended permits with a prominent red call-out circle. This gives the incoming crew total visibility. On the Piper Alpha, this system would have identified the lethal hazard hidden behind a routine overhaul permit before the night shift ever touched the pump. By automating the log, we remove human memory as a single point of failure in a hazardous environment. Step 3 is conducting a face-to-face handover briefing using the mandatory digital checklist as a guide. Both supervisors must review the data simultaneously. Analyzing a glowing digital tablet together ensures there is no discrepancy between what is being reported and what is being received. The protocol requires you to read aloud and verify every item listed under suspended permits. The software forces active engagement. You must expand each tab to verify the status of isolated equipment and check Yes to confirm that you have acknowledged every isolated safety element. This rigid structure requires both the incoming and outgoing leads to confront and resolve operational anomalies before the shift change is finalized. This turns the handover into an active safety audit rather than a passive transfer of files. The final step is executing the dual verification sign-off on the completed log. To seal the document, both supervisors must enter their unique PINs. This applies a digital signature that locks the shift record. Command of the facility cannot be transferred until the incoming supervisor formally acknowledges the current status of all hazardous maintenance. Once the second signature is registered, the status bar shifts to active and displays a green verification badge. Only at this point is command officially transferred. Dual verification ensures the ownership of risk is explicitly accepted and creates a permanent audited account of the transfer. Following these steps creates a permanent record of the platform state. The incoming shift starts their work knowing exactly which overrides are active and which systems are offline. These digital controls serve as a safeguard against error. By locking out compromised equipment, The software ensures safety protocols are upheld by the system itself. Take the time to audit your own facility's permit-to-work system during your next shift to see if these silos exist in your operation. You can download a structured facility handover checklist template using the link in the description. Standardized, digitally verified handovers provide a necessary defense against communication failure. By making reporting a rigid, audited process, you protect the facility and the lives on board.